Hi there. In this short video, we'll learn about how to get statistics of resource utilization of running processes on a Linux system. We'll look at three vital resources that processes would use, mainly memory, CPU, and disk I/O. So these are the three common things that processes do, and we want to find out how much of it is being done. So how do you get the statistics? We're going to learn first how to get these details without using any special tools, just by using basic Linux commands. I'm talking about commands that can be used to open a file, read from a file, use some tools to cut some fields and so on, right? And then I will tell you some tools which are high-level tools to get those same details. First of all, if you want to get information about any running process, you want to look up the contents of /proc. Many process management tools on Linux, be it commands like ps, top, htop, glances, whatever process management tools that you encounter on Linux, they all get details just from one source. They read /proc/PID folder. All these numbered folders that you see here are representative of running processes on a Linux system. For every process that the Linux kernel creates, the kernel would manage them with a task structure, and the representation of all the important statistics of the task structure is found in each of these folders. Now, if at all I want to demonstrate this, what I'll do is I'll launch my own instance of Python in here. So I'll just use IPython for this case. And for making things easier, I want to find out the process ID of the Python shell that's running in this other terminal. So to find out this, find out the process ID, I'll use import OS, and I'm going to type os.getPID. Now this returns the process ID of the Python shell that's running in here, which is 79094. So there will be an entry for 79094 now when you look it up. So if you just do ls/proc, you can see it's right on top. Yeah, you can see the 79094 here. So if you look up what is there inside that folder, if you just say ls/proc/79094, this folder exposes a lot of details that you can get in relation to this process. One file that you want to look up to begin with is a file called /proc/the process ID/status. This file will give you a lot of details, but our focus will be on finding out memory utilization statistics. If you want to find out memory utilization statistics of a process, just look up this file. That should suffice. So if we just do a cat on this particular file, you get a lot of details in here. It tells you about the name of the program, the umask, the process state, the thread group ID, which is actually what you call as PID in the user space, the node group ID, and the actual PID of the process, which is technically we know as thread ID in user space, the parent process ID, tracer PID, all these details are found here. But these fields that start with capital V small m actually means virtual memory statistics. So all the virtual memory statistics are listed in here. If you're looking for physical RAM utilization statistics, you might want to look up all these fields that start with RSS. RSS stands for resident set size, which is actually indicative of how much of memory or RAM is a process residing on, right? It's called resident set size. This is a Unix jargon, so that's what this is all about. So we're going to look for first the virtual memory statistics. An easy way to find the details out is just by using the good old grep command. You can say grep capital V small m /proc/ the process ID 79094/status. So when I run this command now, you get this complete details. It tells you the peak virtual memory usage is this, the current RAM usage is this, current virtual memory utilization is lesser than the peak, which actually means that the process has freed some memory. It allocated about this much of memory, but it freed some amount of memory, so the current utilization is lesser than the peak, right? So this number minus this number is the amount of memory that is being freed by this process at this point. If there's any amount of RAM that's being locked by this process, you'll see this being reported in here. If the kernel has pinned the page tables for the process, you'll also get this being reported in here. These will generally be 0 unless you're writing some real-time applications or user space device drivers, which use specialist APIs, which involve the kernel pinning some pages, or if you use mlock system call to lock pages on your own. That's a topic for another discussion. We'll talk about that a little later. So This high watermark, HWM indicates high watermark, indicates a peak physical RAM utilization of this process. All of them are in KB bytes that you can see here. So the physical RAM utilization is, you can see 48020 KB bytes. The current RAM usage is reported by VMRSS. The actual physical RAM utilization of this process is represented by this particular record. You'll also find how much of memory in virtual address space is used by the data segment, how much is used for stack, how much is used for text segment, how much is mapped by shared libraries, and what is the kernel's overhead for maintaining the page tables for this process. Well, I guess you should know that Linux, mostly on all the modern hardware, runs with virtual memory support, which also means that all the memory addresses are all virtualized through some kind of page tables and the usage of MMU. So the kernel does allocate page tables for every single process to take care of this virtual to physical address translation. The MMU hardware will do the translation based on the page table, and that overhead of the page table is reported with this. If you have configured swap on your system, and if there's shortage of RAM, if your memory goes beyond a watermark threshold, then a lot of unused pages, pages that is not being used for a long time, can be evicted onto disk. If that happens, this will be reported as how many pages or how much of memory belonging to this process has been swapped out or evicted onto swap space. I have a lot of RAM on my system. I don't think I've run out of RAM as yet. On this particular desktop, I got about 32 gigabytes of RAM, and the applications which I'm running here is not even exceeded 8 gigabytes. So yeah, swap usage is almost zero. So yes, this is the overall memory statistics that you find in here, and you can actually watch this out. I can actually run a command prefixing the watch command in here. The advantage of using watch before any command like grep is that it'll execute this command every 2 seconds and update the output. The output is updated. You don't see any changes in here. This time, I'm going to go to this Python prompt. I'm going to allocate a list. I'm just going to say A is equal to list of range of 1 followed by 1, 2, 3, 4, 5, 6. A 1 million element list. And let's see what happens. You can actually see that the virtual address space has increased. So is the physical memory utilization. The peak physical memory usage has gone higher, and even the data segment has gone higher. If I now say A into is equal to 10, I'm just trying to increase the size of the list by 10 times. You can actually observe what happens to the virtual memory size and the physical RAM utilization. It grows accordingly. It's grown by tenfold, so you can see that it's reported in here. It went to a very large number. If I now try to drop that list by deleting all its reference, the only reference I have is this variable called A. Dropping this would very likely free that particular list object being created. And you can see that the current physical RAM utilization is dropped, but the peak remains as is. So is even the virtual memory peak. The current VM size though, however, is dropped, right? So you can actually see the process memory statistics on a running command. So I can do it for any single process. For example, on my system right now, I'm actually recording this entire video using OBS Studio, and as OBS Studio does run as a particular process, I can actually monitor the memory usage of that. For doing that, I can actually say, look up the process ID of OBS Studio. I do a PSAX by grep OBS. Yeah, here's one of them. I think the main process is this. Looks like it. There's a main process. So it is 75245. So if I just do a watch grep / proc watch grep capital V small m / proc / 75245 / status. You can see the memory usage. Well, it looks like it's allocated a large amount of virtual address space. The physical RAM usage might be going slightly higher, or you don't see much changes in here. If you don't see much changes, that means it is pre-allocated memory and is recycling it using memory pool. That's what it is. But the memory usage just keeps going higher and never drops down. You know what it means. It could mean that the process is just growing in memory. It could also be a symptom of a memory leak. It's possible, right? It's not always going to be true, but yeah, some programs could be legitimately allocating lots of memory based on whatever is happening, like in the Python shell that I did here. But sometimes it could also be a memory leak. So you can find that out by monitoring the memory usage, which is not dropping down, right? If the current RAM usage is always at the peak and the current VM size also always at the peak, you can suspect there's a potential memory leak. You might want to check up the application if it's running for a long duration, of course, right? So if it drops below the peak, sometimes it's freeing some memory, allocating again. That's perfectly fine. It's a normal application behavior, right? So these are the details you can find out related to memory usage statistics. If you want to find out CPU utilization statistics, unfortunately that is not available in /proc PID status, but it's found in another file, which is /proc/PID/stat. This particular file gives you details about a lot of features related to a process, but unfortunately all of these are shown up as numbers, so it's not very human readable. I'll also tell you the trick to find out what each of these fields actually mean. You might want to go to a terminal, just say man5 proc, and just learn this magic. In the man page, just do a search for MINFLT. I tell you, it's just a hack, okay? There are many other keywords you can use, but this is one of the things I find it very easy. So when I search for this, it just hops into a place. This man page is very big. You can see it's almost like 42% at this point, so it's very big. It covers information about a lot of files under /proc. The file that you're looking for is /proc PID/stat. Searching for this particular string, unfortunately, this becomes a substring of various other searches, so search becomes more complex. So find some of these unique words like minFLT. I don't think you'll find it anywhere else other than this place. So I use that. So this will tell you about every single field, field 1, field 2, field 3, every field. It tells you what it is all about. So if you want to find out CPU utilization details, you might want to look for field number 14 and field number 15. So I can actually use this. I'm going to just check. Cut minus field number 14, comma 15. I'm using simple cut command, right? Because they're all space separated. So I use field number 14 and 15 and say /proc/75245/stat. So when I run this command now, I need to specify what's a delimiter. So I say delimiter is a space. You find two numbers. These numbers indicate how many ticks of CPU utilization has incurred in user space and in kernel space. This indicates that the CPU executed code in the user mode, mostly the application's code, right? And it utilized so much of CPU ticks. Whereas this much of CPU ticks is used by the kernel space on behalf of this process, right? So kernel could be doing some heavy lifting on behalf of some various system calls and faults, and that's accounted in here. The kernel's accounting and the user space accounting. So these are expressed in ticks. So if you want to convert it to seconds, how do you do that? For this, you can use this trick. You can use getConf and just say CLK TCK. GetConf command will tell you what should be the number that you should divide by to get the number of seconds. So if you just take this CLK TCK, whatever number you get, you just divide this number by this number, you'll get how many seconds it took. Basically, it indicates how many ticks make a second for all these details, right? So you can actually use this feature. So this looks like this took about 2659 seconds. But remember, this is across all the CPUs, not just one CPU. It'll do a summation of all the CPU utilization, right? That's why the number can be sometimes quite large. If you look at the Python program here, the Python process 79094, it is really not CPU intensive. So let's find out what is CPU utilization of this one. It is 79094. Oh, sorry, I made a mistake of the. It looks like it's just about 132 ticks, which means that it's taken 1 second roughly, right? 132 divided by 100. It's like 1 second in user space and less than a second in kernel space. But I want to show you if I run a while true pass skip this CPU intensive, you see the number will increase. You see the number increasing. I can actually prefix with a watch command. Anyways, when I use watch command, I want to backslash skip all the quotes. You can see the user space CPU utilization is steadily increasing. But at some point in time, even the kernel space utilization increases to some extent, maybe because of preemptive scheduling requirements. So anyway, so you can see the CPU usage of this process going higher, right, in terms of seconds. If you want to find out the percentage of CPU usage, It's a little tricky. You need to do some math. You need to find out the process start time, the current time. Basically, you have to do the delta of the start time and current time, and this divided by that delta, right? The duration will give you the actual percentage. So you can get to know the metric on how much overall CPU is being used in terms of percentage metrics. So if you want to find the start time of the process, you can actually use field number 22. You can just do a cut minus field 22 minus delimiter space and say slash proc slash 79094 slash stat. Again, this is expressed in number of seconds since epoch. So sorry, it's not seconds since epoch, it's seconds since system boot. Looks like it. So let me just verify that. Is it seconds or jiffies? It looks like it's in jiffies. I might be wrong. So just the short way to find out is by going to the proc file man page. It's field number 22. That much I know. You can see the start time. The time the process started since system boot. Again, yeah, it's expressed in number of ticks. So you need to actually divide it by CLK-TCK. Use getConf CLK-TCK, and whatever number you get, divide by that. I guess in most Linuxes, I see the number as 100, irrespective of what the Jiffy's value could be, right? It's always 100, just to be consistent with legacy Unix's perhaps. So you can see this. So you can just divide this by this. Okay. You get to know the start time. The start time since system boot is not since epoch. All right. So if you know the delta, if you know the current time and the start time of the process, you know the actual duration the process has been running. You can divide the CPU utilization of the process, divide by the duration, and you get to know the percentage overall, right? If you want to find the disk IO statistics of a process, you can look up the file. You can look up a file slash proc slash the process ID slash IO. This will give you overall IO statistics. This indicates how many bytes was read by the process. It can be on all streams. It can also mean sockets. If we did a read on sockets, even that will be accounted by this. How many bytes are being read? How many bytes have been written across all the streams? It could be all kinds of IO streams. It could be a socket IO, disk IO, right? So for all the IO streams, how much reads are being done? How many writes are being done? How many bytes are being read and written? How many system calls were incurred for read? How many system calls were incurred for write? How many bytes was read from disk? How many bytes was written to disk? And while writing disk, how many bytes got cancelled because, the data they're trying to write is superseded by a newer data for the same location of disk, right? Suppose you're trying to perform some write operations in database where you do constant updates on the same record, very likely the last update will precede or supersede all the previous updates while on the IO queue. So those details you'll find in here. So if at all you want to find those details again, let's say let me do some disk IO in here through the Python program. So I can actually do that by maybe using I can just open a file. I can just say I use import OS I guess already. So I can just say fd is equal to os.open of. Let me open some big file. The big file I can think of is the Linux kernel itself. So let me try to use vm linux hyphen where that file name is. Yeah, let me just select this and say os.o_rd. This is a low-level way to open a file in Python. You can also use the open function, but I'm going to use the low-level syscall wrapper. Okay, so it says permission denied. As a normal user, I don't have permissions to read such a big file. I mean, this file is not owned by me, so I cannot read it. So maybe I can try reading some of the file. Maybe I should be having some files in the downloads folder, perhaps. Any big file in downloads folder. There are a lot of them. I think I'll try opening any one file. Okay, let me just take this. This file seems to be quite big. Okay, open this file. I do this, I can also monitor this entire IO operation. I can say watch cat /proc /79094/IO. Watching the IO statistics in here. Looks like no bytes are being read so far. The moment I do a read, I do a os dot and just do a data is equal to os.read of fd. Right, read the entire contents. Oh, it requires second argument compulsorily. So let me give a large value. I'll just give, let's say, a big number here. Okay, you can see how many bytes got read. Though I requested some size here, maybe the amount it got read is rounded up to this number. Sometimes if you request for a very large size and the file size is smaller than this, it could read the entire file only up to this much, or sometimes it can read more than what you requested. If at all, it does read ahead algorithms. You can also see the read char has increased accordingly. The read system call number will also increase accordingly. If you perform any write operation to a file, the write bytes will be accounted. Right? So this is how it works. So you can actually monitor IO statistics by looking up /proc/pid/IO. If at all you want to monitor memory statistics, just look for all records that start with capital V, small m in /proc/pid/status. If you want to look for CPU statistics, just look up /proc/pid/stat. There are specific fields which tells you information about CPU utilization. You can also get to know about CPU priority, the nice value of the process, all kinds of CPU metrics you'll find in them. Just look up man5 proc to find the same. Right? All right then. So I think I'm done with this video. So if you find this concepts which I covered useful, please do comment so I can make more videos like this, which might be beneficial for many of you Linux users. Thank you very much. So hope to meet you in future videos. Thank you very much.